And we're back. So, this is what I wrote. I think it does what I want it to. So, ignore that. Please enter the account name. While validation loop. I'm not sure if I covered that in your class, Micah, but a while validation loop is basically until you enter what I want you to, we're going to keep asking you. So until what I type in is equal to what I want it to do, I'm just going to keep asking you for it. So the legend 27. Boom. As soon as we get the right name, we move on. So that's more useful for like entering an even number. Well, you entered in an odd number, so we're going to ask you again and again and again and again. Enter the password. So if I type in ASDF, I have 4 attempts left, 3 attempts, 2 attempts, 1 attempt. Guessed. Actually, let's just. Oops. 1, 2, 3, 4, 5. So I want times 2 greater than 1. Should work. And I'm going to get rid of that. So the legend 27. And then that's the second part. So is that the legend 27? What would be really funny is if there is someone whose username or something is the legend 27.
I'm sure there is.
And now.
I heard it in a commercial.
Oh. Maybe you gotta put this up top.
No, that wouldn't matter. Because either way, it's still going to go through with it.
One, 2, 3, 4. Yeah, that's what I wanted. There we go. Because you have 4 attempts and now you have 0 attempts, so you can't type in a password.
So if they have 0 attempts, you just want it to stop. Basically break.
Well, you're given 5 attempts, so 1, 2, 3, 4, 5 to enter in the password. This number, I mean, I could write if times equals 0, don't do anything, but that'd actually be a good thing. So if times equals 0, break.
Yeah, then it would
Yeah, there you go. Nice job. So breaks, what it does is it just jumps out of the loop. It ends the loop you're in. I then came down here. All 3. I added continue. So what a continue does, Micah, because I don't mean to be singling you out, but we didn't cover this in your class, is the opposite. It starts the loop over from wherever it is. So you'll watch. So this first one, we're just gonna the legend 27. Enter your password. Incorrect, 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 and that's just gonna happen, right, for all time. And if I type in the correct one, it's gonna give me access granted, and then it's gonna break out of the loop. But if I type in admin, notice I'm not getting the incorrect like I would down here. Actually, I could print. This is a better example. Try incorrect, try again, try again. Now when I type in admin, what it's doing is that as soon as it gets to continue, it jumps straight back up here and it ignores everything else in the loop. So break jumps you out wherever it is, continue starts you over wherever you are. Make sense?
Yeah.
Okay. Break and continue. If you do while true, you have to have a break in there somewhere. If you do while something is or is not true, or while x is less than or equal to 10, you can change x. But if you don't, you need break, or I guess you could put false. Or not. So you can't put false. You got to put break. That was a big thing that a lot of students forgot in your guys' class, not Micah's, but last semester, is they would have while true and they would forget a break. And it just made their loops never ending, which most of the time is kind of what they wanted for their game, but other times it didn't. And another thing I also saw a lot of is while x equal 10, print, cool, and then they would do break, which exactly, which you could solve by just doing that. So a while break is essentially an if statement. So if you're doing while true, you have to have that break. And then continue is just like, listen, I'm just gonna start all over, right? The rest of my code I don't care about. They did something wrong, so if they type this in, I just want to start all over. And again, it comes down to what type of code you're wanting to write. I don't really have on the fly or quick, easy answers. I mean, I could have like, if you type in the number 4, we're gonna start all over. But when you're coding, that's one thing you want to sit down and go, okay. Like we did with our video games, you guys sat down and was like, these are the things I want to do. This is how I'm gonna do it. When you're writing a code, like my wife, the software developer, she has to think about, well, what if someone types in this? What if someone, instead of the name, types in just a bunch of numbers? What if instead of the name or numbers, they type in code? That's not good. And depending on what it is, it's called a SQL injection. It's where if you have a SQL database, you input SQL code and it then gets ran in your SQL database and it can screw stuff up. You can also do a buffer overflow. So if you don't, and we're not going to do this in this class, this is more advanced programming stuff, more advanced than this. But if you don't know how to accept large values, like let's say I'm asking for your age and I only allow it to be since there's no one, 128, no one's really ever going to be older than that realistically. There may be, but 128, that is 2 to the 6th. Because 256 is 2 to the 8, it's 2 to the 7th. Right, so let's say you've coded it to be a 7-byte number. Do you guys know how binary digits work? No? Okay, let me go over that real quick. So, in numbers, in decimal notation, let me make this a little bigger so when you guys are going back, you can actually read what's on the board. So in decimal notation, what number is that?
100 million.
10 million. Okay. All the numbers here can go from what to what number? 0 to 9. And the order of that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. What happens if we get back to 0? Then you put 1 over here, and then same thing, this becomes a 1. So in binary, you have the same exact thing, except instead of going 2, 3, 4, 5, 6, 7, 8, 9, you only have 0 and 1. So let me jump over here. So if we have 0, 0, 0, what numbers can this be?
1 and 0.
0 and 1. And once this gets to 1, so we have 0 and then 1, what would be the next number that would come?
0. And then 1 goes up there.
1 would go up here. So 0, 0 in binary is equal to what in decimal? That's just 0. Okay? 0, 1 would equal 1. What would the next number be here?
1 0
1 0, that equals
2
and then what's next?
1 1
Equals 3. Fun fact, in any binary number, if you look at the last digit, so if it's,
So zeros are even.
So it's odd. No.
this is an odd number, yep. So, the reason why I'm telling you all this is because if you code for a 7-digit number, right, you guys ever wonder why 256 pops up a lot in computing? Like your IP addresses are 0 to 255, or your RGB values for colors, red, green, blue, are from 0 to 255. You guys ever that's kind of a specific number? It's 0 to 255. How many numbers are in that range? 256. 256 is the 8th power of 2. 2 to the 8th equals 256. So let's get rid of this. So you guys have heard of 8-bit graphics, 16-bit graphics. It's basically, that's where this comes from. If you have 16 bits, you can have a lot more, you can have 2 to the 16 possibilities, which I don't know what that is. That's a lot. So the reason I'm telling you all this is if you code for a 7-digit number or a 7-bit number, 2 to the 7th is 128. No one's going to be older than 128. So in a binary number, that's going to be 7 digits. You guys tracking with me so far?
Feels like it'd be more than that.
No. The cool thing about binary is, well, there's a lot of cool things. So, all right, we're gonna. So 1, 2, 3, 4, 5, 6, 7, 8. So this number here, actually, let's start here. Whatever number is the furthest to the right is 2 to the 0 power. What's 2 to the 0?
1, 1.
This is 2 to the 1, so what's that?
2,
What's this?
4,
What's this?
8,
What's this?
16,
What's this?
32, 64, 128.
So I can make by adding these numbers together, I can get any number from 0 to 127. Well, technically 128. Right, so give me a number, any number between 0 and 128.
56.
56, so we're going to get to 56. Is 56 greater than 128?
No.
It's going to be 0. Is it greater than 64?
No.
Is it greater than 32? Yes. So then we can do minus 32, which gives us what? 24?
Yeah.
Then we go to the next one. Is 24 greater than 16?
No.
Yeah.
Oh, 16.
So then we minus 16, that gives us what?
8.
Is 8 greater than 8? Or greater or equal to 8?
Yeah. So it's 1.
And then we have the rest are zeros. So 56 in binary is 0, 0, 1, 1, 1, 0, 0, 0.
Technically, would the zeros at the end be necessary though?
These ones?
No, the ones at the outside.
Yes. Almost everything is at least 8 bits. Like in computer networking, you guys I'm sure have heard of, have you guys wondered the difference between a megabit and a megabyte?
8 bits are in a byte.
8 bits are in a byte. A megabyte is storage. So your computer's 128 gigabytes of information. A bit is a measure of transmission speed. So your internet, I get 32 megabits per second. That means you download at 4 megabytes a second. So you download like a song and a half per second instead of thinking, oh, 32 megabits, that's like 8 songs a second. No. And I can't remember why that is. I looked it up once, but I can't remember. So all this to say is that if in your code you're creating a box for an age, and you've coded this to only be a 7-bit number, is 7 bits. And I type in, now this is going to be a decimal number. What happens if I typed in
Hopefully it would reject it.
That's right. You want to hope. You would hope that you would code that you could reject it, but if you didn't, and this got plugged in here, you could crash it or cause glitches and have it break. You could break the whole thing. So
That's why computers now just give you options that you scroll through.
actually, I hadn't thought of that, but yeah, probably.
Because it makes it a lot simpler for them.
Yeah, they don't. I don't have to code for it's. Show these numbers and that's it. I never thought of that. That's very clever. But so you got. I honestly can't remember why I got started on this tangent, but.
Sweet.
I don't know. I really can't remember
About
why I
buffering
got.
code.
What?
Your wife buffers code and stuff. That's where you started, and then you said, "Did you guys?"
You're just asking you.
Well, yeah, so you have to code for people trying to break your code intentionally. Why? How I got onto that from this? I don't know. I got too involved in binary and how this works, and I honestly, it blows my mind that everything in your computer, almost everything electronic, breaks down to 1 or a 0.
I don't know.
Yes, no, on, off, open, closed. 2 states. Blows my mind. Like, this pixel, right there, is being told by a computer, 1s and 0s, to be a mixture of red, green, and blue. In the white one, it's all at the same time, but in this black one, it's mainly just blue. And you can even see it. You never did that as a kid? You never went up to a TV screen and you looked and you're like, oh my gosh, I see red, blue, and green, but when I back up, it's gray.
Yeah, I'm not that old. Huh?
You're not that old? Thanks.
Whatever the plasma or
On the old
the thicker ones.
Those are like
the
the
box
bad
ones.
ones.
I don't know.
Yeah, I did do that, but they also have it on like the OLEDs and stuff. And OLEDs versus LEDs, I think what they can do is in OLEDs, and this is probably wrong, I got this from Linus Tech Tips.
My best.
Yes. OLEDs are able to go completely black. They shut off power to things that should be black, and things that aren't, they actually give power to, or something like that. So in an OLED, black is really, really dark, but your other colors are very, very vibrant. But like on your Surface, I'm sure this is gonna be weird for the video, but no, I can't.
Yeah.
Can you see it here? No, I can't. It's too on the TV. You certainly can. You can come in and you can look and you see.
There's a dead pixel. You can see it.
Yeah. If you guys would like to stare at the TV, you guys are welcome to. I have you to 1080, right?
27.
27. Why can't I get this?
Can we break a Surface 3 over our knee and then look at the dead pixels?
Go.
When did this class start? 9:42.
Yeah.
Close enough.
It's
that's
it's
what
the
the-
exact same time
yeah.
as intro last semester.
I know.
but
You would think I'd get it down after
just 2 hours or 1 hour.
after 4 months. I don't know. Okay.
Yeah, we have.
Questions so far? No? Okay. Do you guys have any questions on while loops? I'm gonna make sure I didn't skip over anything important in the book. So if you guys do have questions, figure that out real quick. Nope, that's just gonna go into four loops. You guys just want to start 4 loops?
Yeah.
Cool. All right, so I'll start this video, or I'll end this video, so it's easier for me to do everything.